Alright guys, so sorry that I'm not here in class today, but I'm expecting that you guys are doing the notes along with the video that I'm doing for you right now. So please make sure that you're writing everything that I'm writing down here and answering any questions that I might give to you on the site. And please ask any question to the sub if you guys need it. Today's date is February 31st, 2017. The last couple of days what we've been talking about is scale factor and scale drawing, and today what we're going to be doing is computing length from a scale drawing. So our learning objective is that we're going to be given a scale drawing. We will compute length. In the actual picture, given a scale. So what we're going to do first is take a look at example 1 when it's talking about a basketball court. Vincent proposes an idea to the student government to install a basketball hoop along with a court marked with all the shooting lines and boundary lines at his school for students to use at recess. He presents a plan to install a half-court design as shown below. After checking with the school administration, he was told that it will be approved if it fits in the empty lot that measures 25 feet by 75 feet on the school property. So we want to know, will the lot be big enough for the court he planned and explained? So usually what's happening is that they give us some sort of scale factor that we're going to be using here. So what they're letting us know is that for 1 inch of this drawing right here, it's going to correspond to 15 feet in actual length. So please remember that when it comes to scale factor, we're going to be using a constant of proportionality. And to calculate constant of proportionality is going to be y over x. And in this case, y over x is going to be the drawing length divided by the actual length. So what I have in this scenario here is that the drawing length is going to be that for 1 inch of this drawing here, it's going to correspond to 15 feet of an actual length. So I would suggest you actually draw out a picture here or draw a table here. So we're going to have our scale drawing length, and then we're going to have our actual court length here. And from what we know, 1 inch corresponds to 15 feet. If the length right here is 2 inches, I need to figure out what is this number going to be right here. Similar to that 1 2/3 inches, what is that going to be in feet? So what I need to do is find my constant of proportionality. To get from 1 inch to 15 inch, I do understand that these are different units right here. But what you can do is multiply by 15 to get to my 15 inches. But for those of you that want to have it as the same units, 15 feet is the same as 180 inches here. So you could either multiply by 15 to get directly to your feet, or you can use 180 to get to inches and then divide by 12 again to get what your actual court length is going to be. So what you can do here is that if 2 inches is in the picture, multiply by 15 and that's going to get you 30 feet. Same thing with 1 2/3. What you're going to do is 1 2/3 times 15, 3 5/3 times 15 here. Cross simplify. This becomes 5, 1. This becomes 25 feet. So that means the actual court length will be 30 feet by 25 feet. All right, so that means that yes, the lot will be big enough. For the half